you mind opening us up today?
Dear Lord, we just thank you for this time to come together, Lord, and to learn more about the Apologetics class. Lord God, we thank you for Matt's preparation. We just pray that you would open our eyes to see and open our ears to hear, and we just give you this time, and we ask you to bless it in Jesus' name.
Amen. All right, so we are going to attempt to cover a very light, not very heavyweight, not very deep topic about the origin of the universe. And once we've covered that, then we're going to get into evolution and the origin of man and so forth. So this image right here is actually not the Milky Way. That's actually the Andromeda Galaxy, which is, I guess, one of our close neighbors.
Only 2.5 million light years away.
Exactly, very close neighbor.
M16.
Yeah. And so I thought it was a fitting representation for sort of the cover slide here for this. But I wanted to take a poll to start about who in here, I think I know how the answers are going to go, but who in here thinks the universe sprang from nothing?
Absolute nothing?
Absolute nothing.
Yes.
Okay. Do you believe the universe is a cosmic accident? No? Do you believe the universe had a creator?
Yes.
Yeah. Okay. Why do you believe the universe had a creator?
Because the Bible tells me so.
It's not a bad answer. It's not a bad answer.
The order and the design that required for what creation
Yeah,
is.
so we're going to get into a bunch of that. But I thought it would be fitting to start with Genesis 1 through 3, which says, "In the beginning God created the heavens and the earth. The earth was without form and void, and darkness was over the face of the deep. And the Spirit of God was hovering over the face of the waters. And God said, 'Let there be light,' and there was light." So, there's a variety of beliefs about the origin of the universe. We're going to talk about some of them. Certainly won't cover all of them. Some believe the universe was eternal. And for a while, that's what people thought. The universe was eternal. It was static. Some believe that it has essentially always existed for all of eternity. So infinite into the past. Some believe it sprang into existence somewhere in the distant past. Some believe that we live in a cyclical universe, a universe that sort of is created and collapses in on itself, and is created again and collapses in on itself, and has been doing that for all of eternity. So that it expands and contracts over eons of time. Some believe in a multiverse, which we'll talk a little bit about. And the idea of a multiverse is that there are multiple universes that are existing simultaneously in their own sort of bubbles, their own spheres. We'll talk about why that theory has kind of come into existence. So there's essentially an infinite number of universes, and some of this is to try and justify some of the argumentation around, around why life exists in our universe. And then there are those of us who believe that not only did the universe have a beginning, but it had a creator. We believe that creator is God. Some people believe that the earth, or that the universe had a creator, and don't believe necessarily that it's God, but that there is some creator. Now, what I wanted to start with was, essentially, I'm going to skip to this slide. What I wanted to start with was a... Oh no! Shared. Let me stop sharing. Pause this. So, can you see that now? All right, let me mute the sound here.
Sounds nice.
Fine, I'll leave the sound. Okay. So, this is a website that was created to try and demonstrate the scale of the material universe. And I thought that it was fitting for us to essentially kind of try and visualize that, because I think some people think about the universe and they don't necessarily really think about the size and scale of the universe. And so I thought it was fitting for us to kind of take a look at that and really understand when we talk about big, the big that we're talking about, and when we talk about small, the small that we talk about, which we'll get more into in evolution. But let me turn it off. It was getting a little distracting.
A little bit.
But you can see over here on the left-hand side, this is meant to represent essentially a meter and a human, right? And as you start to scale out, you can start seeing that you get things like elephants, Japanese crab spiders,
Big earthworm.
giant earthworm, the T-Rex, right? These are all things that we can kind of envision in our minds. We watch movies, right? Average size of a house, size of a blue whale, Boeing 747. These are all things that are Statue of Liberty, Titanic, right? We get to something, around a kilometer in size, right? These are all reasonably understandable numbers. But then you start to scale out, really, right? You start to look, that's the size of a marathon, right? 26 miles. The size of Rhode Island, right? You're starting to get to some of the moons of some of the planets, start seeing some of the sizes of countries. We're still not in we're like in 1 megameter size range. But now you're starting to get into things like Pluto. Everybody knows what Pluto is, right? Mickey Mouse's dog, yes, exactly. That's exactly right. Right? Ganymede, right? Still moons, Mars, size of Earth. And then we start getting into some of the stars. Sirius B, the Minecraft world, that's an important one. Saturn, right? Proxima Centauri, distance from the Earth to the moon there, we're at a gigameter, right? Then we get to the size of our sun, right? And as we continue to scroll out, you start seeing that our sun is actually quite tiny compared to a lot of these other stars, right? Polaris, Arcturus, right? And we're getting to a terameter, right, in size. That circle there is a terameter. And we have Antares, right? Distance from Neptune to the sun, Kuiper Belt. Start getting into some of the nebula, right? Stingray Nebula. Now we're at a petameter. We keep scrolling out. You've got a light year. That's that light year. That's how long it takes. That's the distance that it would where it would take you a year to travel at the speed of light. That's how far that distance is. You start getting into some of these other nebula. Now, you remember where the human was? You remember where our sun was? Right? We're still going. You got the Cone Nebula. We're at an exameter in size. That is 1 with that many zeros meters. Cave Nebula, Barnard's Loop, Tarantula Nebula. Now we're starting to get into galaxy size. So you have a Leo 2 dwarf galaxy, right? Sagittarius dwarf galaxy. These are small galaxies. You've got the Triangulum galaxy. We're at a zetameter in size. You have the Milky Way, right? That's us. But our Milky Way is not that big, right? You've got other galaxies that are bigger than our Milky Way, right? Now you're starting to get into sections of space. So the local group, that's the local group of galaxies that our galaxy is a part of, right? So they call it the local group. And so all of these things are not actually stars, these are actually galaxies, which have billions of stars in them, right? Billions of stars, bigger, smaller, the same size as our sun. Our galaxy, the Milky Way, has about 400 billion star systems. You have the Virgo cluster, that's another cluster of galaxies. The Fornax cluster is another cluster of galaxies. So now you're at a yodometer in size. Right? Yoda. Yes. Right? And now you're starting to get further and further. You have parsecs and gigaparsecs. right? And now you're getting to the size of the observable universe. And then if we were to scroll back all the way in, yes, you scroll back all the way
The
in.
Kessel runs.
Going to play.
That's right.
Ludicrous meat. Hey, you saw the same movie.
Yes.
Going to play.
So now you scroll all the way back into a human. And so when you think of big, right, we're talking about another level of big, right? But that's not the extent of what we view as creation. There's also small. So as you scroll in, you start getting down to things like mice, coffee beans, seeds, ants, pencils, right? Grain of salt, millimeters, right? Scrolling down into infrared wavelengths, mist droplets, white blood cells, right? Mitochondria, red blood cells, X chromosomes, down into a micrometer, right? Viruses, ultraviolet wavelengths, right? You're getting even further in, you're starting to get into the size of DNA. Start getting into atomic level stuff, right? Celsius atom, carbon atom, there's an angstrom, which is a distance that they use. There's a hydrogen atom, a helium atom. Then beyond that, you get down into gamma ray wavelengths, picometer, right? Scroll in, start getting to the uranium nucleus. And it goes even further, although they start to say that the sizes get a little fuzzy when you get too small. But you think about the complexity of the universe, not just in its size, but also in the small, bits when we start getting into atoms and nuclei and electrons and protons and quarks. Yeah, actually, if you keep going down, it gets down into charm quark, bottom quark, high energy neutrino, the zeptometer, top quark, right? You're in a yoctometer, which is neutrinos. Keep going until the smallest thing that it measures is actually a plank, what they call a plank.
I need a drama meeting.
Yeah, what's called a plank and string. That's where like string theory comes from. But you can see that there is just an enormous amount of complexity.
Give me another drama meeting.
Yes. It's an enormous amount of complexity in the universe, right? So I wanted to start off because some people, when we talk about the universe, we kind of throw the term around. Talk about stars and things. We throw these terms around and we don't really visualize what it is that we're talking about when we think about the sheer scale of the universe when we talk about it. We kind of think of sort of the bubble we live in. We maybe think about the Earth. We maybe think about the solar system, but we don't go much beyond that to the size of the Milky Way galaxy. Now, I'm a sci-fi nerd, so I'm always looking at stuff like this. I actually played a game called Elite Dangerous where they tried to procedurally generate the Milky Way galaxy. And there were 400 billion star systems that you could travel to because they had the ability to warp to them. But when you start looking at this, and they have these galaxy interactive tools, not like this one, but that actually have like the star systems that you can like drill into and stuff. Where they'll actually, there's programs you can buy where you can actually look at things in the Milky Way galaxy that we can see. But I just wanted to start off with kind of the scale of what it is that we're talking about. So with all of that said, let me go back to presenting. All right, back to the beginning here. So, the prevailing scientific theory of the origin of the universe is something called the Big Bang. Who's heard of the Big Bang? Everybody's heard of the Big Bang, and I'm not talking about the TV show The Big Bang Theory. That's a funny show, though. But there's something called the Big Bang. So the Big Bang posits that the early universe was small, very small, like pinhead needle small, and unimaginably hot and dense. And that the singularity, which is what they call that sort of hot ball of matter and energy, exploded at some point in what they call the Big Bang, very scientific, and began to expand outwards in all directions. And scientists arrived at this theory due to a number of interesting scientific discoveries. But the Big Bang, I have a representation here. I have a couple of representations here where it talks about the sort of phases of the Big Bang. Now, how they know all of this, I'm not entirely sure. So you have this like singularity where time begins, right? And then that's at 10 to the negative 43 seconds. And then at 10 to the negative 32 seconds, there's a post-inflation, and that soup of electrons and quarks and other particles begin to expand. About 1 second in, it's still too hot to form into atoms, so forth and so on. Then at about 300,000 years, electrons combine with protons and neutrons to form atoms, mostly hydrogen and helium. Light can finally shine. At 1 billion years, gravity makes hydrogen and helium gas coalesce to form giant clouds that will become galaxies, and small clumps of gas collapse to form the first stars. And then at about 15 billion years, the galaxies, this is kind of like our present day. So this Big Bang came along basically, prior to the Big Bang, there were people that thought that the universe was sort of static and eternal, right, had existed for all of time. And that the bodies within it, the galaxies, the planets, and everything within the universe kind of just moved around within this sort of bubble of the universe. But then in 1927, there was a guy named Georges Lemaitre. Let me see if I can put his name up there. He was actually a Catholic priest, but he posited that he was also a brilliant physicist. He posited that the universe itself was the thing that was expanding. That bodies weren't actually moving within the universe, but the universe itself was expanding. The way a good illustration that I've seen in like high school science classes is if you take a balloon, right, that's partially filled up, and then you draw dots on the outside of the balloon, and then you blow the balloon up and it starts to expand. Mm-hmm. The dots themselves aren't moving. The balloon itself is moving, and so the dots are moving away from one another, not because they're moving, but because the balloon itself is expanding. So you can imagine that if we have a whole bunch of things inside that balloon that are essentially tethered to the outside of it, as you would expand that balloon, those things, those balls or whatever you have inside there would start moving away from one another. But it's not because those things actually are in motion, it's more that the universe, or in this case the balloon, representing the universe, is expanding, pulling them sort of away from one another. So he posited that the universe itself was the thing expanding, and that's why we when we look out at galaxies around us, we see them all moving away from us, and so the universe itself is getting larger, and everything is moving away from us in all directions. So 2 years after 1927, there was an astronomer named Edwin Hubble. Anybody heard of Edwin Hubble? Probably have heard of his last name at least, right? The Hubble telescope. So he actually was able to observe and notice that galaxies were in fact moving away from us, and the farthest galaxies were moving away faster than the ones closer to us. And they did this through something they call redshift. So there's redshift and blue shift. So redshift is when they see there's like a hue of red on something, that's because it's actually moving away from us, and so you see that sort of light spectrum shift because of the movement. And if something's moving towards you, you get what's called blue shift, which actually gives it sort of a blue hue. And so that discovery basically confirmed that all of these galaxies are moving away from us in all directions. So it sort of confirmed the idea of an expanding universe. So this was sort of revolutionary, right? Because if you can explain that everything is moving away from you, then what happens when you hit the rewind button? Right? Everything starts coming closer to you, right? To a point where if you rewind back far enough, everything will sort of collapse in on itself, right? Everything will start colliding, it will start getting sucked in. And so based off of the rate with which things are moving away from us, they were able to postulate that if you rewound 13.8 billion years, everything would be back into a single point, which is where they get the date of the Big Bang, or the date of the beginning of the universe, right? Now this is actually, we're not going to talk about evolution a lot here today, we'll talk about that next time, but this actually was a huge problem for evolutionists. Because if you have a static and eternal universe, you have an infinite amount of time to deal with the sort of random chance that you needed to create life from non-life, right? To create a living single-celled organism from, you know, a bunch of random chemical particles. But if you have a beginning, now you have a clock, right? There's only a certain number of rolls of the dice that you can throw within that time window, and unfortunately 13.8 billion years, while being a long time, actually presented them with some issues with regard to whether it was enough time for the variety of you know, species that we have just on planet Earth. So this is where the Big Bang Theory came from, and this is essentially still the most prevalent and accepted scientific view that we have today. And while it did explain what we see, I think one of the things I think, now this is my opinion, that it didn't explain is where did those tiny hot particles come from, right? Because again, right, if you look at the second law of thermodynamics, right, you know, you've got a bunch of you know, things that tend toward chaos, right? Things don't tend towards order; they tend towards disorder. That's essentially what the second law of thermodynamics states. So again, you don't actually explain where did the matter and energy come from that could have created this universe, right? Even if you postulate that that stuff existed and that it was and that it exploded and it you know, and the universe is expanding out, you still don't explain where matter and energy came from that could have created that. So that's one flaw that I see in the argument around the Big Bang. And again, there's some people that believe maybe that there was a creator of the universe that created those things and then utilized the Big Bang to actually you know, birth the universe into existence.
Yeah, it was Jesus' voice. It was so loud it sounded like a big bang.
Sounded like a big bang, exactly. So this leads us into, and just here's another image that you usually see around Big Bang expansion, 13.77 billion years, and you know, it's 14.8, 13.77, where it talks about, you know, the inflation of the universe, which sort of expands out to what we see today. So I just wanted to show some of these diagrams. We got to George. But the first thing that I actually want to talk about is something called the cosmological argument. So this is something William Lane Craig pushes a lot, and I'm a big fan of William Lane Craig's debates. I don't agree with him on a number of theological and doctrinal issues, but I do like his the brilliance that he has around arguing for the reasonableness of faith in Christ and the reasonableness of faith in God. And so this is a cosmological argument that he pushes a lot, and I'm going to show you guys two videos around this argument that talks about both the sort of scientific reason why it's more believable or more reasonable to believe in a creator, and then also a philosophical argument for why it's more reasonable to believe in a creator. So the cosmological argument just has three simple parts. Everyone can remember this. Whatever begins to exist has a cause. We know this, right? So these are two premises. Whatever begins to exist has a cause. The universe began to exist. The Big Bang shows that the universe began to exist at a point in time. Therefore, the universe has a cause. Pretty simple argument. It's very difficult to refute that argument. Let's watch a video that talks a little bit about this particular argument and why it's, I hate the fact that I have to end the show, but and why it's more reasonable to believe this argument. I guess it's not a link. Boldly go. Boldly go.
Does God exist? Or is the material universe all that is, or ever was, or ever will be? One approach to answering this question is the cosmological argument. It goes like this. Whatever begins to exist has a cause. The universe began to exist, therefore, the universe has a cause. Is the first premise true? Let's consider. Believing that something can pop into existence without a cause is more of a stretch than believing in magic. At least with magic, you've got a hat and a magician. And if something can come into being from nothing, then why don't we see this happening all the time? No, everyday experience and scientific evidence confirm our first premise. If something begins to exist, it must have a cause. But what about our second premise? Did the universe begin, or has it always existed? Atheists have typically said that the universe has been here forever. The universe is just there, and that's all. First, let's consider the second law of thermodynamics. It tells us the universe is slowly running out of usable energy, and that's the point. If the universe had been here forever, it would have run out of usable energy by now. The second law points us to a universe that has a definite beginning. This is further confirmed by a series of remarkable scientific discoveries. In 1915, Albert Einstein presented his general theory of relativity. This allowed us, for the first time, to talk meaningfully about the past history of the universe. Next, Alexander Friedmann and George Lemaitre, each working with Einstein's equations, predicted that the universe is expanding. Then in 1929, Edwin Hubble measured the red shift in light from distant galaxies. This empirical evidence confirmed not only that the universe is expanding, but that it sprang into being from a single point in the finite past. It was a monumental discovery, almost beyond comprehension. However, not everyone is fond of a finite universe, so it wasn't long before alternative models popped into existence. But one by one, these models failed to stand the test of time. More recently, three leading cosmologists, Arvin Bord, Alan Guth, and Alexander Vilenkin, proved that any universe which has on average been expanding throughout its history cannot be eternal in the past, but must have an absolute beginning. This even applies to the multiverse, if there is such a thing. This means that scientists can no longer hide behind a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. Any adequate model must have a beginning, just like the standard model. It's quite plausible then that both premises of the argument are true. This means that the conclusion is also true. The universe has a cause. And since the universe can't cause itself, its cause must be beyond the space-time universe. It must be spaceless, timeless, immaterial, uncaused, and unimaginably powerful, much like God. The cosmological argument shows that, in fact, it is quite reasonable to believe that God does exist.
So, I thought that it was way better to show that video than to try to describe that video. There's another video that I'm going to show that talks more about the philosophical arguments, but I thought it was interesting, and we're going to talk a little bit about timelessness, but spaceless, timeless, immaterial, uncaused, and unimaginably powerful, right? So for the universe to have been created, it had to be created by something that's outside of the universe.
That's so funny, Matt, because I think that's very close to the definition of Aristotle's immovable mover.
Yes,
And he
unmovable,
was
yep.
way before these guys.
Yes, way before these guys. I don't know that any of us are actually reinventing a lot of these arguments. The next, I'm going to apologize ahead of time for the next video. And the reason I'm going to apologize is because this one actually made my brain hurt. And so I think it might make your brain hurt as well. Because
Yeah,
it
you
talks
just
a
don't get
little
enough
bit
sleep.
about the sort of,
Was that a Monty Python reference?
yes. So this one is going to talk a bit about the philosophical reasons why believing in an eternal universe or believing in infinity is a little bit ridiculous.
Did the universe have a beginning? Or has it existed from eternity past? If it did have a beginning, this raises a question. Did the universe have a creator? In part 1, we explored this question scientifically. Now let's look at it philosophically. Aristotle believed the universe was eternal in the past, but Al-Ghazali disagreed. He pointed out that if the universe did not have a beginning, then the number of past events in the history of the universe is infinite. But that's a problem, because the existence of an actually infinite number of past events leads to absurdity. It's metaphysically impossible. Why? The mathematician David Hilbert illustrates the problem by imagining a hotel with an infinite number of rooms, all of which are occupied. There's not a single vacancy. Every room in the infinite hotel is full. Now suppose a new guest shows up and asks for a room. The manager says, sure, no problem. Then moves the guest who was in room number 1 to room number 2, and the guest who was in room number 2 to room number 3, and so on to infinity. As a result of this shuffling, room number 1 becomes vacant, and the new guest happily checks in, even though all the rooms were already full, and nobody has checked out. And it gets even more absurd. Suppose an infinity of new guests show up at the front desk. No problem, says the manager. Then she moves each person into a room with a number twice that of his own room. So the person who was in room number 1 moves into room number 2. The person who was in 2 moves to 4. The person who was in 3 moves to 6, and so on. Since any number multiplied by 2 is always an even number, all the odd-numbered rooms become vacant, and the infinity of new guests gratefully check in. And yet, before they arrived, all the rooms were already full. It gets even crazier when the guests start to check out. Suppose all the guests in the odd-numbered rooms check out. In that case, an infinite number of people have left the hotel. And yet, there are no fewer people in the hotel. But suppose instead, all the guests in rooms numbered 4 and above check out. In that case, only 3 people are left. And yet exactly the same number of people left the hotel this time as when all the odd-numbered guests checked out. Thus we have a contradiction. We subtract identical quantities from identical quantities and get different answers. These absurdities show that an actually infinite number of things cannot exist in the real world. Here is a second argument Ghazali offers against a past eternal universe. Suppose that for every 1 orbit Saturn completes around the Sun, Jupiter completes 2. The longer they orbit, the further Saturn falls behind. Now, what if these 2 planets have always been orbiting the Sun from eternity past? Which has completed the most orbit? Strangely enough, the number of their orbits is exactly the same, infinity. But that seems absurd, for the longer they orbit, the greater the difference becomes. If the universe has always existed, then an infinite series of past events has been formed by adding one event after another. It's like a sequence of dominoes, falling one after another until the last domino, today, is reached. The problem is that the final domino could never fall if an infinite number of dominoes had to fall first. So today could never be reached. But obviously, here we are. It's today. So the number of events leading up to today could not possibly be infinite. The infinite is nowhere to be found in reality.
It neither exists in nature, nor provides a legitimate basis for rational thought. The role that remains for the infinite to play
is solely that of an idea. What objections might be raised to these arguments? Some people object that, unlike the rooms in Hilbert's hotel, the events of the past don't all exist at the same time. But we can easily tweak the story to get rid of this objection. Suppose the hotel has been under construction from eternity past, one room being added each year. How many rooms would there now be in the hotel? An actual infinite number. So if the past is infinite, that would imply that Hilbert's hotel could exist, which is absurd. Others have objected that an actually infinite number of things do exist, namely numbers and other mathematical entities. However, this objection presupposes that numbers really exist, but this is a highly disputed assumption that most philosophers reject. So if Ghazali's two arguments are right, then the universe is not eternal in the past. It must have a beginning. And we know intuitively that whatever begins to exist requires a cause of its existence. Thus, we are led to conclude that the universe has a cause of its existence. So what caused the universe? Atheist Daniel Dennett says, the universe caused itself. But this is incoherent, because in order to cause itself to come into existence, the universe would have to exist before it existed. The cause of the universe must therefore be outside of the universe, spaceless, timeless, immaterial, and enormously powerful. Much like God.
Absolutely.
All right, does your brain hurt? My brain hurts. Thinking about infinity. So thinking about actual infinity is actually difficult. In this one, you have to think about an infinite amount of time, right? If there's an infinite amount of time in the past, then we couldn't possibly get to today because the past would go on forever, right? And so you can't really think about infinity. Infinity is not like a real thing; it's more of a concept. And so that brought up the question for me: has God existed for all time? Is God infinite, right? So how can God be infinite if infinity can't really exist?
In our world.
So this brings up the question: does God experience time? And if so, how does He experience time? So in the cosmological argument, we said that the cause of the universe must be timeless. So what does timelessness mean? And so there's an article, actually, believe it or not, there's something called the Internet Encyclopedia of Philosophy. It talks about some of the views of God and time. I don't know the source of where this encyclopedia comes from, but the arguments I found compelling. So this is the view that they posited for timelessness. Did I put that in here? No, I didn't. Okay. And it says, the claim that God is timeless is a denial of the claim that God is temporal. Right? So timeless, meaning outside of time, versus temporal, meaning inside of time. First, God exists, but does not exist at any temporal location, so no position in time. Rather than holding that God is everlastingly eternal, and therefore He exists at each time, this position is that God exists, but He does not exist at any time at all. God is beyond time altogether. It could be said that although God does not exist at any time, God exists at eternity. This would be the idea of eternity being a position outside of time. So eternity is not meaning forever. It's meaning this is saying that eternity is a place, right? That is outside of time. So that is, eternity can be seen as a non-temporal location, as any point in time is a temporal location. Second, it is thought that God does not experience temporal succession. So this is things happening one after another. God's relation to each event in a temporal sequence is the same as his relation to any other event. God does not experience the first century before He experiences the 21st century. Both of these centuries are experienced by God in one timeless now. So while it is true that in the 13th century Aquinas prayed for understanding and received it, God's response to his prayer is not something that also occurred in that century. God, in his timeless state of being, heard Aquinas' prayer and answered them. He did not first hear them and then answered them. He heard and answered in one timeless moment. In fact, he did so at the same timeless moment that he hears and answers the prayers offered in the 21st century. So the way I kind of envision this, has anybody seen the Minority Report? Mm-hmm. Right? So you know that they had like the hologram, and they could like view time, and they could swipe their hand, and they could scroll forward, and they could scroll backwards, right? And they could kind of see. I kind of think of God being outside of time and able to kind of like just, you know, scroll back and forth to see any point in time. This is a very primitive view, but it's a way to kind of envision God as being something that's outside of time. Time is something we experience. It's something God created, not something that he necessarily is controlled by. We're controlled by time. We can't stop it. We can't slow it down, right? We can't reverse it. We can't speed it up. But God is all-powerful and outside of time, and therefore time doesn't actually have an impact on him. It doesn't control him. He's not beholden to it. So I actually like this explanation of this timelessness, the timelessness of God essentially existing outside of time and being able to see all things all at once.
In a simplistic sense, like anybody who builds something or makes something is a creator, even a house.
Yes.
The house is bound by the design that the builder gave it, and it can't go beyond that design or
Right.
realm. But obviously the one who built it is free to, you know, go way beyond its limits or
Absolutely.
its bounds.
Absolutely.
Very simplistic, but
And time being sort of a fourth dimension for us, right, is you know, something that we're bound by, but God being the creator of isn't bound by it. So it really comes down to a quantitative versus qualitative difference. So God is an infinite being, but not a composition of an infinite number of things, right? So that is to say, he is not eternal in the temporal sense, but he is outside of time and the creator of time.
Well, Matt, it's often been said that he created time in Genesis 4. You know, God separated light versus darkness, and that was time.
Yeah.
That started the beginning of that.
Yeah, when he created night, yeah. So there's another argument for the creation of the universe, and it's called the fine-tuning argument. Now this goes really deep, but I'm going to show you a quick video about the fine-tuning argument, and then we're going to actually talk about some of the fine-tuned parameters of our universe. So there's an agreement in the scientific community that the universe and the conditions of the early universe were exquisitely fine-tuned. That's a quote. And the question is why? As Christians, we believe we know why. We believe that God is the creator, and he created it with man in mind, with our form of life in mind, and that is why the universe has been fine-tuned to support us, right? The reason that our solar system is where it is in the Milky Way galaxy. It happens to be kind of out on a radial arm of the Milky Way galaxy where there's not too much there's not too much radiation, there's not too much activity happening that could, you know, impact our planet. There are a number of things that have to be just right for us to survive and for us to exist at all. And so we believe that that's because the creator of the universe, God, has actually monkeyed with the numbers, right? He's the one that set up the laws the way they are, the physical laws the way they are, so that we could, you know, exist in this universe. So, some people believe, though, that that is not the case. They believe in the appearance of design, right? And that things just are what they are. And part of the problem that they have is around the probabilities of why our universe exists the way that it does, and the likelihood that our universe would be one that would spring up. And so one of the things that they use to try and combat this is multiverse theory. And the multiverse isn't provable. It's a belief in faith as much as belief in God is. But the multiverse also would require a cause. There'd have to be a multiverse engine, and this video is actually going to talk a little bit about that as well. So we'll play the video, And then after playing the video, actually, you know what? I'm going to go through some of the fine-tuned arguments, and then I'll play the video where you'll see some of those same arguments. So first, I wanted to talk about a particular law that we all recognize, and that is this. Everyone recognizes that, right?
Gravitational law.
This is the gravitational, this is the law of gravity. So this is essentially an equation. So the G over there is the gravitational force, the universal gravitational force. And if you look at the equation on the left, what this is talking about is the actual force of gravity. F is the force of gravity equals the gravitational constant multiplied by M1 and M2, which are the two bodies that are acting on one another, over R, which is the distance between those two bodies. And so this is how you can calculate the force of gravity of the moon and the earth on one another based off of this gravitational constant. Now this universal gravitational constant is the thing that is finely tuned, right? So at the very beginning of the universe, if we were going to take on face value the whole Big Bang theory, right? So at the very beginning of the Big Bang, there were a number of parameters that were very finely tuned to allow for the existence of the universe. So if you take it on face value, forget about where the singularity came from, there was a Big Bang, there were a lot of things that could have happened. If this gravitational force were slightly stronger, just infinitesimally smaller, if it were a tiny fraction of a percent, then the galaxy wouldn't exist, or the universe wouldn't exist. If the gravitational constant were 1/1000th of a gram heavier or lighter, then stars or galaxies wouldn't form. It would result in a life-preventing or a life-prohibiting universe, not a life-permitting universe. The second, so that's one thing. I mean, when you think about that, and there's electromagnetism, there's just a whole host of different finely tuned parameters. There's the other thing, like the formation of carbon. So if you're a Star Wars or Star Trek or a sci-fi nerd of any kind, like me, you probably have heard carbon-based life forms, right? We're carbon-based life forms, right? So you've probably heard carbon life forms or carbon-based life. Carbon is a necessary element for life. In fact, it's the only life that we know. Carbon is formed in the core of stars when 3 helium atoms smash into one another and fuse. This is a nuclear fusion, and it happens to do. It happens because of two forces. They call it the strong coupling force and electromagnetic forces. If these forces were different in the slightest way, it would reduce the production of carbon in the universe, and it would prevent a very necessary element for life. So these are two other forces. These are two other parameters that exist in the universe that are finely tuned to create the life that we know. The third thing is DNA. So, and we're going to talk a lot about DNA when we get into evolution, but if we're just talking about the fact that all life forms have DNA, the mass of a proton is 1836.15267,389 times the mass of an electron.
Oh, well, that makes sense.
Yeah, totally. If this ratio were different by only a small amount, the stability of chemicals would be compromised, and it would prevent the formation of molecules, including DNA, which is the building block of life. We're going to talk a lot about DNA and evolution and the digital code that's actually in DNA that couldn't spring from by random chance. It essentially had to be programmed for cells to actually create proteins. But this is an essential building block, and if, again, the mass of a proton to an electron, if that ratio were off even slightly, it would essentially make DNA formation, very unlikely. The fourth and I think final one before we get to the video and towards the end of the class here is the low entropy. So we talked about the second law of thermodynamics, right? You can observe the second law of thermodynamics if you go to a abandoned city, right? And you see that buildings are crumbling, vines are growing, everything's essentially tending towards disorder or chaos. So at the beginning of the universe, there was a very low amount of entropy. If things aren't maintained, they tend to chaos. But at the beginning of the universe, there's an initial low entropy condition. Sir Roger Penrose of Oxford, he's an atheist, he's a physicist, he doesn't believe in creation, put the odds of our universe's low entropy condition existing by chance at 1 times 10 to the 10 to the 123rd power. Just to give a perspective on the size of this number, the odds are in this number. If you put a 0 on every particle in the observable universe, you still wouldn't have enough zeros to write this number out. So that's how unlikely it is for the low entropy condition at the beginning of the universe, which if the entropy condition was any higher, the universe wouldn't have formed. So that's a staggering number, and the chance that our solar system came together by random collision of particles is 1 times 10 to the 10 to the 60th power. So these are extraordinarily large numbers. We can go into a video real quick, and then I'll have some concluding thoughts, and we'll call it. We'll open it up for questions, actually. So. Does it load? Yes.
From galaxies and stars, down to atoms and subatomic particles, the very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life didn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would, again, be life-prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are three live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really, 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 really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So, in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance, the best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common-sense interpretation of the facts suggests that a super-intellect monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.
So these are cool videos that I found. I've watched, I don't even know how many debates that William Lane Craig had, and while he is writing a systematic theology, and I highly disagree with him about, he's also a believer in sort of theistic evolution, which is essentially the idea that evolution occurred, but it was guided by God, that God used evolution to create man. And so while I have some disagreements there with him, his arguments about the creation of the universe and some of these videos that he put together are really impactful. So, and I thought it was you know, sort of we would cap this off by saying, you know, what does all of this mean? So, sort of in short, it is, and this is probably the understatement of the year, highly unlikely that the universe should exist at all, and even more unlikely that if a universe existed, that it would be life permitting. So I've heard also some arguments made about, you know, that atheists would make, that we're just like really lucky, and they'll use something like the lottery argument, right? Well, it's very improbable for someone to win the lottery, yet we see people winning the lottery all the time, right? It's just improbable, but it can be overcome. And so The problem is that this is a bit of a false argument, because in a lottery, think about, you're churning a bunch of balls inside this like churning machine, and you spit one out and you get a number, right? But a more accurate, so it's like, what's the likelihood that my number comes out of the machine that's spitting the balls out, right? Some of the balls, imagine these are chances that a life-permitting universe would exist, right? So there's a black ball in there, right? And that black ball, there's a bunch of white balls and there's a black ball, and that black ball is the life-permitting universe. We just got really lucky, and that's the one that got spit out, right? But I think this is actually a bad analogy. A more correct analogy is, why would any ball be spit out? Why would any ball be spit out and chosen at all? And if a ball were to be spit out, then why would it be the black ball that is the life-permitting universe?
Why would there be balls?
Why would there be balls at all? Exactly. So, so why does any universe, and you'll hear some of these arguments and debates, why does any universe exist? And if a universe were to exist, it's far more likely that a universe that didn't permit life would exist than it is that a universe that would permit life would exist. So it again goes back to fine-tuning it. It again goes back to design. It again goes back to a mind that intentionally created this and tuned it just right for for it to be a life-permitting universe. And then when you talk about a multiverse, you only compound the error, right? You essentially now, instead of a single universe, a universe, right? You go to a multiverse, but that multiverse also would have to has to overcome the why does a universe exist at all? How did something spring from nothing? And I thought it was neat that the last video there referenced Psalm 19:1. The heavens declare the glory of God. The sky above proclaims His handiwork. Day to day pours out speech, and night to night reveals knowledge. That was a good one. And I think the Psalms clearly point out the obvious, which is that God has put all of this in place as evidence of His existence, right? He's essentially screaming His existence to all who are open to hear it. The problem is that fallen man is unwilling to listen, right? And so man wanting to elevate himself above God or to godhood is unwilling to even listen. Stephen Meyer, we'll talk more about some of his stuff when we get into evolution, but he talks about how all of this physical evidence is essentially goes back to a conclusion. What do we see? What can we observe today that results in order, in something that looks to be designed, that looks to be engineered? Well, we know what creates that. A mind creates that, right? When you look at a watch, not an Apple Watch necessarily, when you look at the old style watches that had gears, right, that some people wear, you look at that and you say, the story of the watch, oh, that's because a bunch of rocks and pieces of tin were on the road, and over millions of years people would walk by and kick those things together, and eventually it formed some gears, and then those gears came together and formed a face, and the salt and sand kind of came together, and the sun baked it and it turned into a face. And then one day I was walking down the street and I saw the watch and I picked it up and put it on my wrist, right? Obviously that makes no sense, right?
There'd be no band.
Yeah, there'd be no band, exactly.
Pocket watch.
And so, you look at things that are designed and you infer to the best explanation. And your inference to the best explanation is that this was designed by a mind. And so when you think about a universe and a world, and eventually we'll get into human beings and life, you look at what was there, and you say your inference to the best explanation is that this was created, this was designed by a mind. And what mind, and the reason we start with the origin of the universe over the origin of man, what mind could create a universe? It has to be a mind that's outside of this universe, that is unimaginably powerful and lives outside of time and outside of the universe that we live in.
And
So
that argument's like Occam's razor, right?
Yes.
Like
yes.
anything that's unreasonable, we chop off and say,
Absolutely.
we're not going there.
Absolutely. But the problem is that over time, it wasn't always the case that religion and science were separate. It wasn't always that they were in conflict. But it seems in America and in the modern world today, there is this conflict between science and religion, right? Science and theism. And so what happens is a lot of atheist scientists will only allow for naturalistic explanations for what they see. And because they're excluding even the possibility of design from their thinking, they just say, we'll figure it out later. Eventually we'll figure it out. The problem is, the more evidence that we find, for example, when Darwin, and I'm sneaking in a little bit of evolution, when Darwin first postulated natural selection, he didn't know about the inner workings of cells. He only understood that the cell was the basic building block of life, but a cell was sort of a gelatinous blob. When you actually dig into the structure of a cell, you have many machines, you have code, you have replicators, you have all of these different you have readers and correctors. There's all these different things that are working inside the cell that Darwin had no idea about, right? And so when you look at things like that, and we'll get more into that with evolution, all of this stuff, the universe, the fine tuning, how our bodies work, how cells themselves work, all of that starts leading you down the path of an engineer built this. And being an engineer, I kind of like that. But this engineer was a little more powerful than I was. I am. But I thought it would be fitting to end with a scripture. Psalm 14, 1 through 3. The fool says in his heart, there is no God. They are corrupt. They do abominable deeds. There is none who does good. The Lord looks down from heaven on the children of man to see if there are any who understand, who seek after God. They have all turned aside. Together they have become corrupt, and there is none who does good, not even one. So this is a fallen world, and it's only by God's grace that any of us are illuminated to the point where we can even think in this way. So go ahead, Rod.
Can I just quote, it just came to my mind as I'm watching this, and that is this: "For the invisible things of him are clearly seen, being understood by the things that are made, even his eternal power and deity, so they are without excuse." Okay? For although they knew God, they knew it, and didn't honor him as God or give thanks to him, but they became futile in their thinking, and their foolish hearts were darkened. Claiming to be wise, they became fools, and exchanged the glory of God for immortal God, for images resemble mortal man, birds, animals, and creeping things. Therefore God gave them over to their own lust. And it's so important for us to watch every existence, no matter what it was, Media Persia, Greece, Rome, and now we're in today's, and we're seeing everything collapsing in the United States, not just here, around the world.
Mm-hmm.
God gave us over to their own lust, and he backed off his new conviction. And look where we're going. And so the invisible things of God are clearly seen, being understood by the things that are made, even his eternal power and deity. So we're all without excuse.
Yes.
They see him, they don't want him, and the battle is the scientist, or their God is Satan. That's the bottom line, theologically.
Yeah, they try to elevate themselves. Go ahead.
And to piggyback on that point, when we think of creation, we think of also, not everybody thinks of it, but thinks of common grace and the restraint of common grace, which was brought up there. If he lifts his hand just a little bit and changes the calculations of anything, it's no more. You know, right now everything's being held together by this common grace, by his restraint on this.
And I think that God's general revelation, right? Again, I use the term, he's screaming.
Yeah, absolutely.
Through the evidence, he's screaming, I'm here, I'm behind it all. And we're just, some of us, not all of us, are too stubborn to see it, right? We're just too stubborn. We want to make ourselves, we want to elevate ourselves above God, and as a result, they exclude the idea of anything supernatural, from the argument. Did you have something you wanted to say?
Yeah, first of all, thanks for all your research, really interesting stuff.
Sure.
I like the videos a lot. The last video, at the end of it,
Mhm.
seemed like the experts were kind of like saying like they really didn't know what happened, and then they had the Bible verse after that. I've been half the experts don't even believe like they what they even say, that they just don't want to admit it.
Yeah, so a lot of, and I've seen a lot of stuff where a lot of experts are coming around because again, the more we discover, the more obvious it becomes, right? The less you can argue against design. Now, you may not call it God, for evolution, it could be space aliens, right? They came and seeded the planet or something, right? But some intelligence created it. But when you get to the creation of the universe, which is why I started here, is because space aliens can't create the universe because they're inside the universe, right? So you have to imagine, for a designer for something like that, you have to imagine an all-powerful or an unimaginably powerful mind that exists outside of the universe to create the universe, right? And if that unimaginably powerful mind created the universe, then it's also the best explanation for what created life. Go ahead.
And this anti-God position of modern science is relatively recent.
It is.
Henry Morris told us, most of the founders of modern science, Johannes Kepler, Isaac Newton, were Bible-believing Christians.
Absolutely. Absolutely. But they just chalk that up to being a bit more primitive and to that being more the social norm of the day. Go ahead, Dave.
You think about Carl Sagan, who is an atheist, but he talks billions and billions about primordial soup and
The cosmos always was, always will be.
and the leaves and the trees and and the stuff, and he would talk like that, and everybody would be like, he had these series on PBS way back when, the Cosmos and stuff, and everybody would think, oh, he's one of the wizards of smart, but he really. People would say, well, then how did this come before that? And he'd be like, the soup, the primordial soup, I don't know.
Well, and what ultimately they're left with, they talk about us, who are Bible believing. Have you ever heard the term God of the gaps, right? So they say we see this evidence, and I'll air quote evidence because some of it's not really evidence, but they have these gaps, right? So you talk about macroevolution and species evolution, right? So evolving from one species into another species, not microevolution, which is obvious and evident. That's just adaptation. But when you talk about macroevolution or species evolution, they can't find any transitionary forms, and so they say, oh well, God of the gaps, right? You're just saying God because we have these gaps in our knowledge, and they just postulate that. Over time, we'll get smarter, we'll discover more, and we'll figure it out.
The fossils don't prove.
The problem is it's going the other way. The more that they discover, right? First there was DNA, and then there was junk DNA, and now they're finding that the junk DNA actually wasn't junk DNA. It was actually it actually performs a function. The more they discover, the more it is trending towards design. The more it is trending towards this being a mind behind everything. So. What I actually find, and it's the same thing with abortion, right? The more we, before they used to say it was a clump of cells, nobody makes that argument anymore. Nobody. The reason is because science has advanced to the point where we know that that's not true, right? We know that DNA is formed the minute of conception, the blood type, the DNA, how tall that person is going to be. All of that stuff is sorted in the code, in that new unique human body. All of that is sorted out in the code, and so the more we discover as science marches on, the more that it actually is backing up what theists believe around design, right? Around a God that actually created it all. So, wanted to start there. Yeah, go ahead.
The book Stephen Meyer wrote,
Yeah.
Darwin's Doubt.
Darwin's Doubt.
It talks about the fact that there are no hybrid or a
Correct.
hybrid form. No transitional forms
Correct.
in the fossiliferous strata at all.
Correct, yeah, correct. We'll talk about the Cambrian explosion and
The
a bunch
Cambrian
of-
explosion.
a bunch of that stuff. Any questions about the universe stuff?
Mhm.
Do you guys all still believe that God created the universe?
Absolutely.
Just check out, make sure I didn't turn any of you off to it. Go ahead, Bob.
I don't know if you're going to get into this, but Louis Giglio has a really
Yes.
excellent video out. I think
does.
it's called How Great Is Our Guide?
Yes, I saw it.
And he goes all the way out. There's a galaxy out there called the Whirlpool Galaxy
Yep,
Oh, yeah.
that's supposed to be the star generating galaxy. And in the center of that galaxy is a laminin star. And the laminin star is a glue star like. And we have a laminin molecule in our bodies that's the same thing. It's the glue that holds the rest of the cells together. And he brings that stuff out, and it's awesome.
yeah,
awesome
your wife
video.
actually turned me on to that special, and then I went home and watched it, so yeah.
Is that where they make the washing machines? Whirlpool, Cosmos?
And Matt, you don't have
Because
a
I could
link
use,
to the privileged planet either, do you, on this?
I don't on this yet.
Because that's another, it's not like, it's not as in-depth as the fine-tuning thing,
Yes.
but it's just like, oh, all these things are coincidences.
Yes.
It just had to happen this way for us to have
What's
life.
that? Was that Hugh Ross?
It might be. I don't remember who the author was. It's called The Privileged Planet.
Yeah, I've seen it. But the yeah, I just when I think about this stuff, it always like one of the things I always tell my wife when I get to heaven, the first thing I want to do is like explore the universe. I'm such a sci-fi nerd, like that's what I want to do too.
We'll have eternity to do it.
Yeah,
but it
so-
may not be there since the heavens are gonna.
That's
Yeah.
who knows?
Yeah.
Who knows what'll
That's,
be there? But
yeah.
I just think it is so cool, and so when I think about it, I just think how can any of us believe this happened? That sprang, out of nothing.
There you go.
So
Really.
ex nihilo. All right, who wants to close us in prayer?
Gutierrez.
Ivan, you want to close us in prayer?
Sure. Father, how great thou art.
Amen.
Mhm.
It is wonderful to see your creation, to be part of your creation, to be your image bearer. We thank you, Lord, for just so many things that we don't know, and things we're learning about you. And we thank you, Lord, every day for our salvation, for this time together. We thank you, Lord, for our brother Matt and our brothers here who are together and just learning together and glorifying you, honoring you, and doing this. The more we know, the more we're in awe of your holiness, of your wisdom, of your design. We are just in total awe of this. So we thank you, Lord, for that. You have the privilege of learning more. And we ask during this Thanksgiving week, Lord, that we give thanks to you, Lord, for giving us our minds and our intellect to be able to take this information and take it inside us, Lord. So we ask that you give all of us a great week with our families and to be thankful for what you've done for us, each one of us individually, Lord. Be with us and guide us, Lord. In your name, Jesus.